Okay, so I'm looking at problem 2 from homework 4, where we're asked about the function f of x equals x plus sine of x, and we're asked to show that this function is never decreasing. So another way of saying that is that we have to calculate the derivative of the function and show that it is never negative, because when the derivative is negative, that's exactly when the function is decreasing. So we now know how to take the derivatives of trig functions. So the derivative of sine is cosine. That means the derivative of this function will be 1 plus cosine of x. Now we know negative 1 is always less than or equal to cosine of x, which is always less than or equal to 1. So therefore, 1 plus cosine of x is always greater than or equal to 1 plus the smallest value that cosine can take, which is negative 1, which is equal to 0. So since f prime is always greater than or equal to 0, f of x is never decreasing. However, we can see that it is not always increasing, because if cosine of x reaches this minimum value of negative 1, then f prime of x will be equal to 0. So when cosine of x is equal to negative 1, we have that f of x is not increasing, because f prime of x is equal to 0. So that's the point where there is a horizontal tangent line to the graph. So the question is, when is cosine of x equal to negative 1? Well, if you think about the unit circle, it's going to be when we've gone halfway around the circle or on the far left side. So cosine of x equals negative 1 implies that x is going to be equal to, well, pi is one value, but we could also go around the circle another time and get to 3 pi, then cosine would be negative 1 again. Or we could go around the circle in the opposite direction, then we'd go from pi to negative pi and then negative 3 pi and so on. So the values where cosine will hit negative 1 will be negative 3 pi, negative pi, pi, 3 pi, and so on, continuing in multiples of 2 pi in both directions.